Hello everyone, today we are going to be discussing the relationship between electric potential and electric field. We were going to start out by defining each of these terms. Electric potential is the amount of work required to move a unit charge from one reference point to a specific point against an electric field. It can also be defined as the potential energy per unit charge of a point in a static electric field, or voltage. Electric field is the region of space around a charged particle or between two voltages, and it exerts a force on charged objects within its vicinity. First, we are going to demonstrate electric fields. So electric fields are represented with field lines. So right now you can see that I am drawing a positively charged particle, and when you have a positively charged particle, field lines point away from the charged particle. And if you have another positively charged particle that has more lines around it, that shows that positively charged particle has a stronger charge. So the density of the field lines around a charged particle tells us the strength of the charge. If you have a negatively charged particle, the lines around the charged particle will point in towards the negatively charged particle. Early on this semester, we were taught Coulomb's law, which taught us that like charges repel and opposite charges attract, with a force proportional to the product of the charges and inversely proportional to the square of the distance between them. So we can use the equation F equals K times Q1 times Q2 over R squared to show us that when you have a positively charged particle and a negatively charged particle, their field lines will end up connecting, moving from positive to negative. Next, we will be talking about electric potential. When talking about electric potential, it is important to discuss the relationship between electric potential and work. So, in moving a charge in an electric field, you must apply a force. And this force is applied over a distance, so therefore work is done. And then if you do work on an object, you give it energy. And in this case, the energy it is given is electric potential energy. Work done per unit charge in moving a charge between 2 points in an electric field is electric potential difference. So an equation showing the relationship between electric potential and work is V equals W over Q. V is the electric potential difference, W is the work, and Q is the charge. Now I'll be doing an example problem to demonstrate the relationship between electric potential and work using the equation V equals W over Q. So an example problem we have is a potential difference of 10 volts exists between 2 points, A and B, within an electric field. What is the amount of work required to move a magnitude of charge of 2 times 10 to the negative third coulombs from point A to point B? So I'm going to draw a positively charged particle and a negatively charged particle. So we'll call the positively charged particle point A and the negatively charged particle point B. And we have the equation V equals W over Q. And we know that V is 10 volts, Q is 2 times 10 to the negative third coulombs. So you're going to do 10 volts is equal to W over 2 times 10 to the negative third coulombs. And then you'll divide 10 volts by 2 times 10 to the negative third coulombs to get work. And your answer is 2 times 10 to the negative 2 joules. Now that we know a little bit more about what electric field and electric potential are, we're going to define the relationship. So electric potential is a property of the field that describes the field's action. Electric field can only exist if there is a difference in potential. Electric field is defined as the negative space derivative of potential. Electric field is a measure of force per unit charge. Electric potential is a measure of energy per unit charge. An equation that we can use to adequately describe the relationship between electric potential and electric field is E equals delta V over D. In this equation, E is the electric field strength. Delta V is the electric potential difference between 2 points in an electric field. And D is the distance between these 2 points. So we are going to do an example problem to demonstrate this relationship in this equation. So I'm going to draw an electric field between 2 charged plates. So we have a positively charged plate and a negatively charged plate. And we'll call the positively charged plate plate A and the negatively charged plate plate B. If this field is separated by 10 meters and the electric field strength is 50 volts per meter, we want to find the electric potential difference between these 2 plates as you move the charged particle from plate A to plate B. And we're going to write 50 volts per meter is equal to delta V over 10 meters. You will multiply 50 volts per meter by 10 meters and cancel out the meter units, and your answer is 500 volts. I hope you now better understand the relationship between electric potential and electric field.